How does freezing work as a food preservation method? Have you ever wondered how freezing keeps your food fresh for longer? Let's break down the science behind freezing as a food preservation method. Freezing works by lowering the temperature of food below the freezing point. This causes the water inside the food to change from liquid to solid ice crystals. When this phase change occurs, it slows down or even stops the growth of microorganisms. It also reduces the chemical reactions that lead to spoilage, effectively extending the shelf life of your food. From a thermodynamic perspective, freezing involves removing heat energy from the food into main stages. First, sensible heat is removed to cool the food down to its freezing temperature. Next, latent heat is extracted. This is the energy needed for the phase change from liquid water to solid ice. Interestingly, this happens without changing the temperature of the food. Once the water has frozen, more sensible heat is removed to lower the food's temperature to the desired storage level. The formation of ice crystals plays a vital role in preserving food quality. Rapid freezing creates many small ice crystals. These smaller crystals cause less damage to the food cells, helping to maintain texture and flavor. On the other hand, slow freezing forms larger ice crystals, which can rupture cell walls and degrade the food's texture. Several physical properties of food affect the freezing process. For instance, when water freezes, it expands and becomes less dense, which is why ice floats. However, in many foods, the overall density increases as water turns to ice and the structure changes. The specific heat of the food also changes after freezing begins. The amount of heat needed to change the food's temperature decreases because energy is used for the phase change rather than for temperature change. Additionally, thermal conductivity affects how quickly heat is removed from the food. To ensure the best results, it is important to maintain a consistent and sufficiently low freezer temperature, ideally 0 degrees Fahrenheit or below. This helps prevent ice crystal growth and moisture loss, which can lead to freezer burn and degrade food quality. There are various freezing methods, including air blast freezing, plate freezing, immersion freezing, and cryogenic freezing using liquefied gases. Each method controls the rate of heat removal and ice crystal formation differently, impacting the final quality of the frozen food. In essence, freezing preserves food by thermodynamically removing heat to convert water into ice. This process slows microbial and chemical activity, while careful control of freezing conditions helps maintain food texture and quality.